Okay, today we're going to solve for the area under the graph of some parametric functions. Okay, this is going to be excited. Okay, so what do we have? So let's maybe here, you know what? Let's find an arbitrary area under the graph first. Let's do area under the graph of x. Oops, maybe I should do it in black. It's easier to see. X equal r theta minus sine theta, and y is equal to r1 minus cos theta. Okay, why don't we find the area under the graph of this? Okay, so what's the equation? The equation is a integral of y over of dx, right? And now, oh yeah, I forgot to tell you where to integrate from. Okay, so of 2 pi. Yes. Okay. So a to b, right? This will be your normal functions, okay? So let's make it in terms of t and yeah, in terms of t, right? So we see y, we can substitute y in here, this y in here, right? And dx, we could make this to be dx, okay? So that basically we have that a, b, y, let's call y g of t. How about called y of t? Yeah, let's make it less confusing. Y in terms of t. Do the derivative of f of t, so x of t dt, and this would become alpha and beta, which is this. Oh, that should be 0, that should be a t. Okay, so I mean, it should be a theta. Yes, so we express this in terms of theta. So you know what? Let's put the equations in here. Okay, so a would be what? Would a be? A would be in terms of theta and x and y. So alpha and beta, which is from 0 to 2 pi of y of t, which is r1 minus cos theta. And this, we're going to take the derivative of that. This would be, the derivative of this would be in terms of theta would be r minus, so what is the derivative of sine of theta? It's cos theta, right? Okay, nothing changed. And this will be dx d theta, so you can multiply theta over here to give us a theta like that. Maybe there should be a bracket. Okay, now substitute that in. That will be of dx, right? So in dx, yeah, r minus cos theta d theta. Okay, so that is an equations that we have right now. Okay, cool. So we got 1 minus cos theta and 1 minus oops, derivative. This should be yeah, right? So nothing to talk about it. Okay. Oh wait, oh my goodness, I took the derivative wrong. This would be r, right? you distribute the r inside, we will get 1 minus cos theta. Yes, it should be r1, so we have an r in front, be 1. Okay, because of the derivative, you can take the sign with a constant now. Anyway, so this would be r square 1 minus cos square. Okay, maybe I can take the r outside. We're going to have, oops, cos square, this should be outside, yep, cos theta square d theta. Okay, so it'll be 1 square minus 2 cos theta plus cos square theta. Okay, now let's take the integral. This would be r squared, right? And the derivative, the integral of 1 would be just be theta, right? Okay, so that would be theta. Cool. And now minus 2 cos, the derivative of cos is a minus sine, right? So plus sine theta. Okay. And what is the integral, not the derivative, my bad. The integral of cos square theta. What would that be? Okay, how about I make this over here? Let's erase all this. Find the integral of cos square theta. Okay, so how can find the integral of cos square theta? Okay, what can we substitute cos square with that would make this integral a little bit more easier? This would be integral of 1/2 1 plus cos 2x. Okay, so the integral of this, we can put a constant outside, and let's replace 2, we have theta here, right? 2 theta. Let's do 2 theta equal to u. Du d theta would be, you guess it, 2. Okay, so this means that du will be 2d theta. Put this down here over 2. Okay, so basically du over 2 equal d theta. That's what we want to substitute here for the d theta. Over here, I think I did post a video about how to take the integral of this. All right, so we're going to have 1 plus cos u. Oh, I say put that cos u and du over 2. We can turn this over here, so it's really 4, right? So equal to 1/4 of the integral of 1 would be, we do it in terms of u, so we got u plus the integral of cos u. What will be the integral of cos? This would be sine, right? It will be sine u. Okay, we can know u will be equal to 2 theta, right? So 1/4 2 theta plus sine 2 theta, and you can see the two u cancel out, so we're going to have this should be, yep, we're going to have 1/2 theta plus sine 2 theta. Well, space there a bit. I hope you can still see it. Let me write again. Clear 2 sine theta plus 1/2 theta plus sine 2 theta, and we say we evaluate this from 0 to 2 pi. Okay, evaluate this from 0 to 2 pi. So basically we use sub 0 in where it's supposed to be. So 0 in here, that would be r squared 0 plus 2 times sine 0. That would be 0. Sine 0 is 0 plus 1/2 0. So this term would basically be 0. So let's not worry about this because we don't have a lot of space. So I'm just going to do with 2 pi plus 2 sine of 2 pi also be 0. Okay, so all this term cancel out, plus 1/2 2 pi would give me r squared. 2 cancel out, so it's pi 3 pi r squared. Okay, so the area under the graph of this function right here would be 3 pi r squared. Thank you for listening.